For today's session on the dais is Honorable Keynote Speaker, Mrs. Praveena Velusamy ma'am. So I heartily welcome to you, madam, for this dais. I welcome the Chief Organizer of an international conference, Honorable Dr. M. Ambedkar sir, and I salute and heartily welcome all those dear participants. The topic for today's presentation is Unraveling the Mysteries of Machine Learning. The topic, as I have mentioned, going to deliver a talk. Honorable Keynote Speaker, Mrs. Praveena Velusamy ma'am. She is a research scholar serving at University College of Engineering, Anna University, Tiruchirapalli. So with this brief introduction, now I request to you, madam, please start your presentation on today's topic, Unraveling the Mysteries of Machine Learning. You are most welcome.
Thank you, sir. Thank you so much for your brief intro.
It's visible, madam.
Yes, sir. Yes. So I hope my audio, video, and presentation is good to go.
Yes, ma'am. Please continue.
Yes. So happy evening, all. First of all, I would like to extend my greetings and thanks to Dr. Ambedkar sir and his team for making this huge initiative. Start my presentation with putting up a question that what is the main difference between the word artificial intelligence and machine learning? So coming to the answer that artificial intelligence is like a broader concept of machine. So it will be having the smartness of machine, and it is like that wherever comes the word smartness, there stands the domain artificial intelligence, right? Because we are having so many artificial intelligence applications in our day-to-day life. So on other hand, the domain machine learning is like, it is like a subset of artificial intelligence. So it will be like emphasizing the data, and it is like learning from the data, and it will be identifying the patterns, and also it will be making a better decision and quick decision with minimal human intervention. So this is what the thing, what is the main difference between the artificial intelligence and machine learning. So let me simplify the thing for non-technical participants in this presentation, in this discussion. Like let us consider the platform of YouTube and Netflix. So everyone will be using the platform called YouTube and Netflix in our day-to-day life, right? So even now my lecture series is streaming in YouTube, and we all may be watching in YouTube platform also. So let us consider the scenario that you are watching the series in YouTube platform, like live streaming in YouTube platform. So the next day, that is tomorrow, you will be getting some playlist from the Ambedkar sir's channel. So how it is happening, how the recommendation system works. So here comes the question, right? How the machine is identifying our individual behavior and identifying our individual requirements, right? So here comes the domain of machine learning. So likewise, considering Netflix also, you might be watching some horror kind of movies. So it will be giving some horror kind of movie suggestions continuously. If you are watching some emotional dramas or web series, then it will be giving some kind of suggestions, whatever videos you are watching. So these are all comes under the data. So everything here is like data. So it will be collecting the data from whatever videos you are watching and how many hours you are watching that video, even the keywords you are searching, whatever keys you are searching for the videos, like bed cursors, live stream, webinar series, like that you will be searching now. It will be giving the whole playlist and it will be storing the data of that keyword also. So everything will be stored as a data, and using that data, your machine will be having the past your machine will be learning from past experience, and it will be giving the personalized instruction according to the individual behavior. So this is what really happens in the machine learning process. So let me come to the relationship between the artificial intelligence, machine learning, and deep learning. So let me categorize it like this. That is, deep learning is a subset of machine learning. Then machine learning will be the subset of artificial intelligence. So in this, artificial intelligence will be having the broader concept of machine learning as well as deep learning. So in machine learning, you will be having the data and your model will be learning from that data. And after learning, your model will be got trained and it will be behaving according to the individual behavior and according to the individual perception. So this is what the picture happens in the machine learning. So coming to the deep learning is one step advanced to machine learning. So in this machine learning, in this deep learning kind of thing, you will be having the neural networks. So neural network in sense like what neural network we have it in our brain. The humans will be having neural networks in our brain now. So like that it will be having in the deep learning. But in deep learning, we will be having the neurons like the weight updation, activation function, bias, and so many kind of things. So that kind of neurons will be effectively predicting as compared to the human. So what the machine is having the efficiency equally to the human being. So this is what the thing happens in the deep learning. So this combination of machine learning and deep learning techniques will make the domain artificial intelligence, and this artificial intelligence will behave smarter using this machine learning and deep learning. I hope this is the relationship between these three major domains is clear now, even for non-technical background participants. So whenever you comes to the domain of machine learning, you will be having two major important things, that is data and learning. So what is data? So data is the thing whatever we are collecting from the sensors or domain knowledge or experimental runs. So the data can be in any form, as we had seen the lecture of Vaidegi ma'am yesterday, right? So ma'am has mentioned that data can be in any form, right? I think you remember that. So likewise, in the machine learning also, you can have data in any form. Like you will be having the data in pictures, or you will be having the data in Excel file, or you will be having the data in PDF, or even you will be having the data as a text document. So whatever data it may be, you can take it from the source like sensors. So let me simplify the thing. All will be having the digital watches, right? We will be wearing the digital watches. So in that, we will be having the heartbeat sensor, right? So it will be continuously monitoring the thing and it will be sending the data to the mobile phone or whatever device we had been connected, right? So in that, after collecting the data, it will be giving some personalized instructions like your blood pressure level is very high today, so kindly take the medicines or take the rest, or you had been walking so much kilometers today, so kindly have a peaceful sleep. Like that, you will be having some personalized suggestions, right? So these suggestions will be coming after the data collection and after your model has been learned from that data. So this is what the two important things that happens in the machine learning. That is, one thing is data and another thing is learning. So I hope this image is visible for you. Let me have a laser pointer here. So this is the the traditional programming. Before machine learning, we had some traditional programming. So in that traditional programming, we had a data as an input, and even we had a program as an input, and from that we will be getting an output. This is what the traditional programming done. But in machine learning, you will be having the data as an input, and even you will be having the predicted output, or whatever output you wanted is as an output, which will be given to the trained model, and after that you will be getting a program output. So this is the major difference between the traditional programming and machine learning. So coming to the domain of machine learning, you will be having three kinds of learning, that is supervised learning, unsupervised learning, and reinforcement learning. So these are all the kinds of learning algorithms which will be categorized under machine learning, and each categorization will be having a particular kind of algorithms. Like in supervised learning, you will be having the linear algorithm, polynomial algorithm, KNN algorithm, logistic algorithm, and so on. Likewise, in unsupervised algorithm also, you will be having so many kind of things. I'm not going into depth of it because it is more technical. So let us understand some basic things, and we can go for some application kind of things, right? So coming to the first learning type, that is supervised learning. So what is supervised learning? So supervised learning, in sense, it is like a labeled data set. It will be having the labeled data set kind of thing. So consider here, you will be having the raw data input, and you will be having some kind of labels. That is, you will be giving this raw data and labels as an input. After that, you will be processing an algorithm. After that, your model will be get trained. Then the output will be predicted under the supervision. So whatever the result you are desired to, you will be getting that result. So in supervised learning, you will be having the labeled data set, and there are two main categorizations in supervised learning, that is classification and regression. So coming to the classification kind of thing, so in classification, you will be having the categorical targeted variables. So let me simplify the thing. Everybody is using the email box, right? That is your Gmails, right? So in that, you had been noticed that your spam mails will be in a separate folder, and your primary mails will be in the separate section, right? So how it is getting classified? All the advertisement kind of things is categorized as a spam, and all the primary things, that whatever the business things or the educational things, will be given in the primary session. So this kind of classification is done using the supervised learning classification. So in supervised learning classification, you will be having the kind of algorithms like support vector machine, random forest, KNN, and naive Bayes. So these are all the algorithms we are using for the classification kind of thing in supervised learning. So coming to the regression part, so regression part will be used in the continuous target variables. So for example, consider the share market analysis. So in share market, you will be getting the GDP, right? So the GDP will be changing time to time and frame to frame. So it is like a continuous target variable. So it will be continuously changing, and you will be continuously predicting the things, right? So in this kind of continuous target, we will be using the regression kind of things in supervised learning. So coming to the next part of learning, that is unsupervised learning. So in unsupervised learning, you will be having the unlabeled data. So in supervised learning, you will be having the labeled data, but in unsupervised learning, you will be having the unlabeled data. So in that image, you can see that here you will be having only the raw input data. Then after that, you will be giving to the algorithm part, and after that your model get trained, and after that your output has been predicted, right? This is what the thing happens in the unsupervised learning. So unsupervised learning is a kind of thing where you will be not having any labeled data. So it will be having only unlabeled data. So in that, you will be having two type of classification, that is clustering and association. So what does mean by clustering? So in general, Clustering is like you will be grouping the similar kind of data in one kind. For example, consider this image. You will be having a circular kind of data in one part, and square kind of data in another part, and triangle kind of data in another part. So this is kind of clustering, right? You will be grouping the similar kind of data in one part. Like that, you will be clustering the thing. So the clustering algorithms like PCA, that is principal component analysis, mean shift algorithm, K-mean clustering has been used for your applications. So coming to the association type of unsupervised learning. So in this association type, you will be having the relationship among the variables. So whatever data you are collecting in the data set, you will be having some kind of relationship to the data. So let me simplify the thing with the real-time example. That is, you will be having the weather forecasting system in Latur district. So you are having so many places in Latur district, and you will be having the so many kind of sensors fixed there. Like you will be having a temperature sensor, then humidity sensor, then air pollution sensor, noise pollution sensor. Like that, so many sensors has been fixed there. And you will be getting the continuous data from that sensors. So you will be having one kind of data set. So in that data set, you have to predict and say whether the Latur district will be getting sunny tomorrow or rainy tomorrow. This is what the kind of prediction you had to do. So for that, you had to get the data of the temperature sensor as well as the humidity sensor. So you will be having the relationship among the data items in the data set. So this is what the association rule is. So you will be associating the values of temperature sensor and humidity sensor. After that, having the relationship among them, you will be predicting that it is going to be sunny tomorrow or it is going to be rainy tomorrow. This is what the thing actually happens in the association. So coming to the next important kind of algorithm, that is machine learning thing, that is reinforcement learning. So this kind of reinforcement learning is very important for the artificial intelligence domain. So this kind of artificial intelligence domain will be using the trial and error method. So in reinforcement learning, what you will be doing now, you will be having the labeled data set and unlabeled data set. So both you are mixing up. Here the supervised algorithm as well as unsupervised algorithm comes into play. Both will be playing the game. So for example, consider the self-driving cars, that is Tesla cars. So in Tesla cars, you will be having some kind of instruction as an labeled data set and some kind of instruction as an unlabeled data set. So this is what the thing really happens in the machine learning. So in machine learning, we might be having so many kind of things like hidden Markov chain, Q learning, state action, deep Q learning, like that. It will be more technical again, so I'm not going in depth of it. So coming to the next important kinds of reinforcement machine learning, we might be having two kinds of things, that is positive reinforcement learning and negative reinforcement learning. So in positive reinforcement learning, your machine will be get rewarded for every correct decision it makes and every positive decision it makes. So let us consider an example of some funny thing, that you are having a dog in your home and you are training a dog to give a shaken, right? So your dog is perfectly giving a shaken to your neighbor. So you will be rewarding him with some chicken pieces or biscuits, right? So likewise, our machine has to be rewarded with some data set or with some kind of a specialized algorithm for every correct and positive reinforcement. So this is what the thing actually happens in positive reinforcement. Then coming to the negative reinforcement, in negative reinforcement, it will be punished. That is, your machine or your model will get punished for every wrong decisions or negative decisions. So punishment in sense, it is not like, hey, you put a 50 sit-ups or you write 100 times an assignment, like that. It is like the loud buzzers, or it will be like error messages or warning messages, that kind of things, right? So this is what the negative reinforcement learning is. So this is the perfect visualization of our practical applications. So you can see that all type of applications will be coming under each domain of machine learning. That is, some kind of applications will come under supervised learning, and some kind of applications will come under unsupervised learning. So all our recommendation systems, like what YouTube is performing, or Facebook is performing, or Netflix is performing, or even Amazon is performing the recommendations, right? So all those recommendation systems will come under the categorization of clustering in unsupervised learning. So this is what the thing, you can refer it later in depth, so you will be getting a more idea about our day-to-day applications, what kind of learning it have. So coming to the process of machine learning, so the machine learning process will start from data gathering to model evaluation. So data gathering in sense, as I mentioned earlier, you will be collecting the data in any source, that you will be collecting the data in sensors, or you will be collecting the data from knowledge experiments, or any kind of things you will be collecting the data. So after collecting the data, you will be having a data preparation. So why we had to do data preparation here? We can just use the data what we have collected now. So why we are using the data preparation here? So data preparation is we cannot use the raw data as it is, because our raw data will be having the unavailability of data, or it will be having sometimes the replica of data, or it will be having some kind of null values in our raw data. So if you are using the raw data to train the model, in sense, it will be decreasing your efficiency of the model, and it will be not giving the prediction whatever you wanted, and it will be not giving the accurate prediction. So for every data gathering, you will be having the data preparation using some feature selection engineering, or some feature selection methods. We will be having so many kind of methods, like entropy, binary entropy, like that. So it will be in the technical part. So after that, after data preparation, you will be having a choosing of model. So you will be choosing the model, like you will be going to design an application in the supervised thing, or in unsupervised thing, or in reinforcement thing. So you will be choosing the model. After choosing the model, you will be training the model according to which you have chosen. For example, if you have chosen the supervised learning, means you have to choose the algorithm which is under supervised learning. So if you had chosen some clustering kind of thing, now you will be choosing the clustering type of algorithms. So this is what the training model happens. So after training the model, you will be gauging the model. So what is the gauging of model? It is like accessing the data, that is accessing the model or evaluating the model. You will be evaluating the model, that whether your model is performing good or your model is giving the perfect accuracy. Suppose your model is not giving the perfect accuracy, then you will be going for the step called parameter tuning. So what is parameter tuning? In sense, you will be having the optimization technique to make your prediction accurate, and to make your prediction to improve the efficiency of that model. So that is called as a parameter tuning. So in parameter tuning, you will be having the Bayesian optimization technique, cross-validation technique, and boosting algorithms. Even you will be having some kind of score values also. So that kind of things will be come under parameter tuning. So after parameter tuning had done, you will be moving to the testing part. So remember one thing, if you are collecting the 100% of data now, you will be using 70% of data is for training, and 30% of your data is for testing. So this is the kind of proposition you have to split up the data for training and testing, or else you can go for 80% of testing and 80% of training and 20% of testing. So the major portion should be in the training part. After that only you will be going for the testing part with a minor amount of data what you have collected. So this is the next step we will be having the model evaluation. Once your model got trained and you will be tested with the data, now you will be going for the model evaluation. So in that model evaluation, you will be predicting the values, accuracies, and F1 scores. So this is what the thing happens from data collection to model evaluation. So let me give some quick glimpse up of real-time research project, what I had done using the supervised learning algorithm. So this is the kind of multidisciplinary thing. It is related to some genetic inheritance disorder prediction. I had been used the light gradient boosting mission. That is the kind of supervised learning technique. That is ensemble supervised learning technique. So in this research, I had been categorized the three important diseases like single gene inheritance, multifactorial disease, and mitochondrial disease. Not only that three important kinds, but also the subkind of each disease. Like you see in the slide now, you will be having single gene inheritance will be having some sub diseases like sickle cell anemia, cystic fibrosis, like that. And coming to the mitochondrial part, you will be having some diseases like Person syndrome and coenzyme Q10 deficiency, like that. You will be having some sub kind of diseases. And in mitochondrial also, you will be having some sub diseases like cancer, high blood pressure, and cholesterol level, diabetics, Alzheimer disease, like that. So this kind of model, what I had trained is it will be predicting the three major kind of disease, that is single gene inheritance, mitochondrial disease, multifactorial disease, and also it will be predicting the subcategories of each disease also. So this is what my trained model will be doing in this research work. So coming to the whole architecture of this research, I will be collecting the data. So you can collect the data from Kaggle. So Kaggle is like a database repository where you can get the data sets for your project and research purpose, or even you can go for some real-time databases where you can collect the patient's data from hospitals or from authorized medical agencies. So after the data collection, you will be going for the data pre-processing. As I said in the earlier thing, you will be pre-processing the data. That is, you will be removing all the messy things in data, and you will be forming the perfect splitting of data. That is one for training and one for testing. Then after that, you will be training the model. Here I had been trained this model using the light gradient boosting algorithm. So this kind of algorithm will be giving me the more learning rate and the boosting rounds. I had also done with some kind of algorithms to compare the accuracy. So I will be showing the chart in the upcoming slides. So after that, training the model, you will be testing the model, and after that you will be predicting the diseases, right? So you will be not only predicting the three major kinds, but also you will be predicting the sub kind of the diseases also. So this is the sample data set what I had been. There are 22,083 data. In that 43 is an independent variable and one is dependent variable. And this is the sample data. You will be having a data set like this. And this is the process what you have to follow from data collection to model evaluation. That is, I had been discussed every step very clearly in the previous slides. And this is the kind of computational calculations to boost up my algorithm. So these are all the kind of calculations for boosting the rounds in the algorithm. That is, while training, we can boost the algorithm to get more accuracy and more efficiency. So this is what the calculations I had made to boost the algorithm. So coming to the next finding, this is the finding of different algorithms. That is, I had been used the decision tree classifier, random forest algorithm, k nearest neighbor algorithm, and all those kind of algorithms, and getting an accuracy, precision score, FN score for a substrate algorithms. This is for the single gene inheritance disorder alone. So after that, you will be getting the mitochondrial disease alone, and after that you will be getting the accuracies for multifactorial disease alone. So this is the combined chart of all the disease and all the algorithms using the light gradient boosting machine. So here you will be having the decision tree, random forest classifier, support vector machine, XGBoost, and light gradient boosting machine. And you will be having the macro average and weight average of each algorithms. So this is the final comparison chart I had made to show my accuracy. So in this decision classifier, you will be getting the 42.25 accuracy, and in random forest, you will be getting 48.72. And this is the support vector machine, you will be getting 48.25. So in this chart, you can see that light gradient boosting algorithm, that is n-assemble supervised algorithm, is getting the more accuracy, and even it is also getting the more F1 score. So we can conclude that this kind of algorithm will be best suitable for this model, right? So while you are working in a research project, or while you are working in the real-time application projects or real-time application kind of thing, you should compare with all the kind of models. So after comparison, you will be getting an idea that what algorithm is efficiently working and what kind of parameter is giving you the efficient result. So you can declare that kind of algorithm and you can move on to that. So this is what the practical implementation is. Let me show it quickly. So this is the platform of Google Colab. So you can see here, this is the platform where we are used to train the model. So you will be putting up your data set in this, and you will be training the model. This is it is mostly like a cloud platform. You will be working in online, and you can able to share the Colab with all the team members you are working with. So here you can see the coding part. I think it's loading, right? It's the screen is blank. I hope so. Yes. So you will be getting trained of models using this Google Colab. In this training, you can also have some kind of data representation parts. That is, you can have the pie chart, and you can have some graphical representations like bar chart, histogram, and so on. And even you can have the heat map. The heat map will be showing the correlation among the diseases. So correlation in sense, it will be showing how frequently the disease is affecting the particular patient. So if the disease is affecting very frequently, then it will be becoming the genetic disorder, right? It will be spreading to our family, or it will be spreading to our inherited members, so like that. So this is what the thing we actually do and predict in this model. So I think now the screen is visible, and you can see the representations in the graphical representation, that is in the histogram format, in whiskers plot format, and this is the kind of thing how we are training the model and getting the accuracy. So you can even have this kind of pictorial representations to have the statistical values. And coming down, this is the kind of heat map. This is called as an heat map or correlation map. So where you can have the correlation among the diseases, and you can even have the correlation to find the genetic disorder of your family, and whether it is going to affect you genetically, or it is going to be okay or not. So this is the thing you can train and visualize. And after training the model, you will be getting accuracies and confusion matrix for each model, so that you can predict which model is going to be good for your application. So Coming to the next part, that is these are all the reference you can go for if you are really interested to work with this kind of machine learning and genetic disorders. You can go for this kind of journal references and online references. It will be most best resource for referring this genetic disorders using machine learning. And this is the kind of information corner. Today in this world, we are using so many AI tools for even for research. We are using so many AI tools, and even for all the things like Chat GPT, we are using daily, and we are referring the things. Likewise, this AI tools will be helpful for the job seekers, because nowadays the searching of job is like. A typical task, right? Because in LinkedIn we will be having so many fake recruiters and fake job notifications, so that you can use these kind of AI tools to have the priority of recruiters, and to have the best job seeking options. So this is what the thing I had to present today. And I personally believe that learning, practice, and consistency will make every man to success. So what I would say is that learning will never stop in any stage of our life. So we have to do learning in all the stage of life, and we have to enhance ourselves in this automated world. That is, everything is becoming artificial intelligence and everything is becoming automation. So we have to know something, that is what the machine is doing, how efficiently the machine is performing like human. So this is what the thing I have to conclude. So happy learning. Now the session is open for queries. So if there is any queries, you can ask.
Thank you so much, ma'am, for the wonderful presentation. Now it's a time for discussion. Dear participants, I would like to request you all, if you have any query, please discuss with keynote speaker.
Hello, sir.
Hello, sir. Good evening.
Good evening, madam. Actually, how we can decide this model is good or not?
Sir, it will be depending on your application, sir. As I said, if you are going for the continuous targeted variables, then you can go for some regression kind of things. If you are going for the categorical variables, now you will be going for some type of classification algorithm. So it will be like how the data you are getting, and what kind of predicted output you want. So you can decide accordingly, sir.
And how we can deploy model, madam, in machine learning?
You can. Yes, sir. So you can deploy a model like you will be collecting the data initially. So you will be collecting the data. After collection of data, whether you can go for some real kind of data also. It is not mandatory to take the data from Kaggle. If you are going for the real kind of data, it will be very fine. So you will be collecting the data. After collecting the data, you will be processing the data. So to have some, to avoid some messy kind of things, you will be processing the data. After processing the data, you will be choosing the model and you will be deploying the model. So in this deployment stage, you will be having more technical kind of things, sir. So you will be having so many algorithms, you will be having so many kind of optimization techniques to enhance your efficiency.
Okay, madam. One more question is there from my side. How to avoid overfitting?
Sir, the overfitting in sense, in every data, we will be getting some kind of overfitting, sir, because the data will be having some unrealistic things in some cases. So overfitting, we can avoid by using some optimization kind of things, that is advanced kind of optimizations, sir. So it will be reducing your overfitting, and it will be increasing the efficiency or performance of the model.
Okay, fine.
Anybody else? Dr. Swami Shukla, sir, please.
Hello, good evening, Dr. Bedkar sir, Principal sir, Prashant sir, and good evening, ma'am. Wonderful presentation. I am from the medical field, so I could pick up some important aspects of your today's presentation, but still It was very much, comprehensive. Yeah, we are also using some, the apps in nowadays in the medical field, and definitely they are also helping us. But we are just going through the front, what we can get on a screen, but we don't know much about what are the machines and how these tools works and everything happens. So I think the inputs are very important, what we are putting. Thank you, madam. Thank you very much for your wonderful presentation. Any other machines are there, applications are there where we can use it in a medical field? Thank you.
Yes, sir. Thank you so much for your valuable comments, sir. I also accept that in medical field nowadays the machine learning kind of thing is deploying more, and it is acting very efficiently. And even the researchers also having some kind of research to improve your domain. So, as you were to acknowledge your question, that there are so many kinds of things, sir. In machine learning, we will be having so many kind of applications in medical field, and as you said, we are having that is the collecting of data is a crucial part. So if your data is messed up sometimes it will be not giving that much accuracy. So to control all these things and to have some kind of good predictions, we have to go for some kind of advanced models. So I think and I hope in future you will be definitely getting the help from our domain to your medical field. I hope I had answered your question.
Yeah, ma'am. Thank you. Thanks a lot, ma'am.
Thank you, sir. Thank you.
Ravindra Amarkar, sir. Please.
Thank you, Prashant sir. Good evening, Praveena madam. Good evening, Bedkar sir. My surname never spelled correctly by Prashant sir. Prashant sir, I am Ravindra Ramatkar. Okay. Praveena madam,
Yes, sir.
many congratulations to you, as we have enjoyed simplest form of excellent presentation.
Thank you, sir.
I am a layman or a nursery learner as far as subject physics and the artificial or computer science subject or artificial learning is concerned. I am a layman, so I am just nursery learner for it. But however, your simplest form of presentation took me to think for a student assessment and machine learning, because I am very much concerned with the education since 35 years of my services.
Yes, sir.
My worries is that so I have understood little about the data processing, data collection, labeling, unlabeling, classification, flagging, etc., and understood very little. However, output I understood it. My concern is, you see, as I told you, learning from student assessment. How a teachers learn from a student assessment, and student assessment through using AI. My question is handwrites of the students. Okay. And suppose in a class 100 students are there, and if we give him a question, write a 50 lines or 50 lines, 30-40 lines about the water pollution. Okay. Say, so we will be receiving the different handwrites. Okay. Now my question is, what kind of challenges will you face while collecting the data, while classifying the data, or in your own language, while processing the data? So what can be the challenges from the handwrites received from the 30 students of a class 1 and in this connection, second question will be how the deep learning, particularly when you have used the neurons, as a mind of biology, I just remembered. So how deep learning will solve those challenges from the data received? So these are the two things. These are the two things to me. Sorry, madam, whether I don't know whether I have put up the question in a expected manner or not. I don't know.
Okay, sir. Let me explain the thing. Nothing worries about it. So to address your question first, so if you're collecting the handwritten scripts now, you will be either collecting it in a photograph form, like you will be having some scanned copies or some kind of things. So you will be you have to do some kind of CNN kind of algorithm. So if you are going for the image data set in sense, you have to go for the convolutional neural networks as you address the deep learning models now. So it will be consisting of some convolutional neural networks. So that kind of convolutional neural networks will be having so many layers of filtration. So in that layers, in every layers of filtration, your handwritten notes or your handwritten scripts will be filtered. So after getting filtered, you will be going for the final prediction. But in language sense, you have to go for the domain called NLP, that is natural language processing. So for identifying the language or to come up with the language kind of things, you have to go for NLP. But for the thing what you have to identify in the image, you can go for the deep learning kind of thing. In deep learning especially, you can go for the convolutional neural networks to train your models. I hope I had answered the question.
Yes, just to pose me two challenges. One for the language, and another for the content. So my worry is there any challenges if you see the scanning of the handwrites? What are any other challenges that a AI engineer will face? Any other challenges other than these languages, other than pictures? So what can be the challenges for bringing the collecting the data, or what do you feel it? What I mean to say, I understood that, I learned it that the students' assessment through the scan paper, that has been assessed using the AI. But there are challenges. So what will be the challenges from those other than this what you spoke now too?
Okay, sir. So the main challenge is that apart from the images, you had a challenge in model training. So you have to make the model to have the optimization result. That is, you have to get the result of that hand script, or you have to get the result of what the thing you had given as an input. So in model training, you will be having first a challenge as messy up of data. So you will be sometimes, or it is an unavoidable situation that you will be having messy up of data, and even after some filtration techniques and feature selection engineering, we will be having some kind of biased data. So that kind of biased data will affect our model. That is the first challenge. And second challenge is that overfitting of model. Once your model is getting so many things as in his neurons or as in the thing, it will be becoming the thing like overfitting. That is, it will be giving some least kind of value, or it will be having some more kind of value like that. So these will be the two challenges according to me in the scenario what you have said.
Thank you, madam. Thank you very much, because I am going to answer certain the pro forma. I am going to answer certain pro forma where I found the what they asked me what would be the challenges from this handwrites. So I must thankful to Praveena madam as well as the Dr. Betkar sir, that fortunately this kind of session was in the evening, and this has immensely helped me understanding this AI more better. because I heard, but your simplest pharma explanation was the excellent presentation. So I congratulate you, madam, and Dr. Bedkar sir for arranging this kind of session for me for today. Today, solving my problem. Thank you, Bedkar sir.
Thank you, sir. Thank you, and best wishes for your thing.
So thank you so much. I think nobody is there now. Dr. Sanand Shukla sir, Ramatkar sir, Prashant sir, for your nice questions and sharing some views regarding to the topic. Thank you so much. Now I request the chief organizer of an international conference, our ideal principal, Dr. M. Bedkar sir, to conclude the session. Please welcome.
Thank you, sir. Thank you so much.
Thank you, sir. Now I move towards the vote of thanks. Shri Kumarswami, Mahavidyalaya, Ausa, District Latur, in Maharashtra State. As we know, dear participants, we are organizing internationally conference every day, webinar series. For today's session on the dais is Honorable. Yes. On dais was Honorable Praveena ma'am, who came with a new topic, that is unraveling the mysteries of machine learning. Madam have covered all the aspects, all the details regarding the topic. What do you mean the machine learnings? Then the difference between artificial intelligence and machine learnings. Then supervised learning classifications, reinforcement machine learnings, positive reinforcement, and experimental findings by giving many examples. You have clarified, ma'am, all the details. So I am very, very thankful on behalf of the organizing committee members. You have paid your valuable time to the session today and delivered a wonderful lecture in front of us. Thank you once again. I thank the chief organizer of an international conference, Dr. M. Bedkar sir. Especially thanks Dr. Shukla sir, Ravindra Ramatkar sir. Now I announce Ravindra Ramatkar sir. If you are there, sir, please. Once I was in MA, studying in MA, our head of the department, Dr. Sangewar sir, because being the students of literature, he always saying that what's in name. This was a quote, famous quote, which have been we find among the literature in the drama of William Shakespeare, who always says that what's in name. Either we call by the name proper or maybe say something. So that was in that sense. I will definitely next time will use your name as a Ramatkar, not Ramatkar. So thank you for the nice discussion with the keynote speaker, and I should thanks all those dear attendees who joined regularly to the session. Thank you so much once again to you all. Now kindly request you all please fill the feedback link which is given in the chat box. So with the kind permission of chief organizer, I declare today's session is over. Thank you once again, Praveena madam, for your valuable time. Thank you so much.
Thank you so much, sir. Thank you, and best wishes for your lecture series.
Hello, Bedkar sir.